Hi friends, this week topic is rate of return analysis, and I will go shortly, and after that I will leave the rest of the questions for you guys to solve and then send it to me. It's gonna be an homework for you guys. We change our mind. We are not gonna make midterm for this remote educational system. I'm gonna give you guys this as a homework, and you guys are gonna submit it. Then I'm gonna give you guys a project for the for midterm. Is gonna be a quantitative analysis. So each homework and project is gonna count as your midterm. Is gonna be 40%, and 60% is gonna be your final. So let's start. What we are gonna do today, we are gonna define the internal rate of return, and then we are gonna rate of return calculation, how we are gonna make the calculations. Then decision criteria, like we are gonna make an analysis, which one is gonna be you guys are gonna choose or not, which one is gonna be better options. Okay, first of all, rate of return analysis. Rate of return analysis is the most frequently used exact analysis technique in industry, because rate of return is a single figure of merit that is readily understood, and calculation of rate of return is independent from the minimum attractive rate of return. And the major characteristic of this rate of return analysis is because not the variable with like the figures, like if it is like $1,000, either like $1 million, whatever it is, you are gonna say, okay, I want my rate of return is gonna be 10%, 5%, 7%. It's just one figure. So the variable of these figures doesn't change with the amount of money. When internal rate of return, if we talk about this one, the internal rate of it is interest rate at which the present worth and equivalent uniform annual worth are equal to zero. So like that, there is this internal rate of return is gonna be not benefiting, neither costing, is gonna be zero, neutral. So this is neutral. Then after is kind of like minimum rate of return you are asking. So it's more than that one in order to benefit your interest if you are the borrowing or investing. So we have two different criteria. For borrowing, the interest rate paid on the unpaid balance of a loan such that the payment schedule makes the unpaid loan balance equal to zero when the payment is made. And for investment, the interest rate earned on the unrecovered investment such that the payment schedule makes the unrecovered investment equal to zero at the end of investment life. So when we make it with the example, if we show it, let's have this. Okay. So let's say we have a cash flow. We borrow $5,000. Okay, and then we want to pay it with 5 equal payment, which is 8% interest. So when you calculate it, it's gonna be 1,252.28 cents. This is our cash flow. Okay, then according to bank, this is the unrecovered investment at beginning of year. So the first year is gonna be they are not gonna get anything, right? The second year, the first year, sorry, at the end of first year, it's gonna be $5,000. The capital need to be get back, but first year the bank gets 1,252.28 cents. Then when you subtract it, it's gonna be 4,147. Why is that? Because we want to make it an interest rate put here. If you subtract each other, it's gonna be less than that amount. But we are putting the interest rate on it. Okay. So when we see the investment is going to be 5,008% is going to be 4,147 8% is going to be 331. Subtract each other from these guys, and in order to get this amount, you are going to have 852, 920, 994, 1,000, 1,159. What is this one? This is think about the bank giving you credit. So the first year when you pay, your capital is decreased. Like when you want to close up, you need to pay 4,147, because the rest of it, whatever you pay, the between this amount is gonna goes to the interest for the bank. That's why this is the the capital what you are paying. Like for example, when you pay 5,000, you pay just like 1,252. It decrease just 850, around $850 from the capital. The rest you need to pay. Then the second year, when you pay 920 out of 1,252, the 331.82 is goes to interest of the bank. So let's delete these guys, and then how we are gonna calculate rate of return is basically as we said. Sorry, let me go through it again. Go back. Go. Sorry. Cancel. Yeah, like this is different. Okay. Draw. Okay. When we need to convert various consequences of investment into cash flow, and the PV of benefits minus present worth of benefits minus present worth of cost is gonna be 0. So what we said here, we said sorry. This goes to wait. Okay. Never mind. Okay. Present worth of benefits minus present worth of cost is gonna be equal to 0. That means like when we divide, it's gonna be 1. It's gonna be the equal. We want to make present worth of this concept is gonna be 0, and net present worth is 0. And either we are gonna make it present worth, net present worth, or net equivalent worth, which is equivalent uniform annual worth is gonna be 0. Or you can say present worth of benefit is equal to present worth of cost. These all 1, 2, 3, 4, 5 equations is gonna be exactly the same. We are gonna calculating the rate of return. Let's have an example. Let's do it in this way. Okay. So an engineer invests $5,000 at the end of every year for 40 years. An engineer invests 5,000 a year at the end of every year for 40-year career. If the engineer wants $1 million in savings at retirement, what interest must be investment earn? So let's do it. So let's say, okay, instead of net present worth, let's say net net future worth is gonna be 0. Okay, so if we say every year the guy is paying $5,000, right? $5,000. So we can make it to the future. Let's see, $5,000. Let's see, $5,000. And we can say it future to annual. So every year is paying $5,000. So we are gonna make it in the future. And the interest rate we don't know, and then for 40 years is gonna be plus $1 million. $1 million, right? This guys is equal to 0 because net future worth is 0. That means this 5,000 multiplied by f over a I 40 is gonna be equal to $1 million, which means f over a I 40 is equal to 200. So when we go our table, if we look the 40 years f over a table, which one is 200, we will see I is equal to 7%. Okay, so this question is done here. When we go back our slides, let's see another example, which is a cash flow. The first one is 700 is paid. The present value is 700. Then after that, the cash flow is 100 in the positive. Then the second year 175. The third year $250, and fourth year $225. Let's make it our cash flow diagram. If we draw a cash flow diagram, we know that this at the beginning is gonna be $700 at the beginning, so it's in the minus direction. Then after that, 100 is gonna be in the first year, then the second year, then the third year, then the fifth year, right? 2, 3, 4. And this guy is 175, 250, and 325. We can make it equivalent uniform annual worth is equal to 0. Either way, you can make it like present worth, whatever. Okay. So in this time, I will choose equivalent uniform annual worth. I can ask in the questions like choose this way in order to find the interest rate. These guys, as we see, is arithmetic gradually increased. So we can say, okay, this guys is 100 is an A, right? So in positive direction, we just put 100 in the positive direction plus. As we see, 75, 75, 75 is arithmetically increased. So 75 multiplied by A over G, I, and 4 years. Minus, we have 700 here, but is present worth, so I will convert it to the annual series, and I and 4. This is equal to 0. As we see, there are two unknowns. Okay, sorry. We have AG and I here. So it's implicit formula which we don't know, like if we take everything on the right, on the left and right side there is I unknown, so it's not explicit directly we can solve. So we need to use trial and error method, which is, if we say try I is equal to 5%. So let's try I is equal to 5%. 100 plus 75 A over G. This is 5% and 4 years, right? Minus 700 P over A. Sorry, A over P. 5% for 4 years. This is gonna be plus 11. Okay, this answer is given plus 11. So it's not equal to 0. So then I will say, okay, 5% it doesn't work. So let's try I is equal to 8%. So I will use this formula again, 100 plus 75 A over G, 8% 4 minus 700 A over P, 8% for 4. Then after that, when we apply this equation, is gonna give us minus 6. So it's costing this or we are losing money. Here we are earning, we are losing money, is not 0. So it's, we can understand this is minus, this is positive. So it's gonna be between 5 or 8. So I will try lastly 7. Try 7%. Then after that I will say 175 multiplied by A over G, 7% for 4 years, minus 700 P over A. A over P, 7% for 4 years, so it's gonna be around 0. So I would say 7% is my rate of return. Let's go back. Here, okay. Maria borrowed a student loan of 9,000 each year for 4 years. No interest is charged until graduation. Then the interest rate is 5%. If Maria makes 5 equal annual payments, what is each payment? What is the internal rate of return for Maria? Let's see. So Maria start school and take a loan for 9,000. Right? When at the end of beginning of the year is paying his credit for the school, then the first year, at the beginning of the first and the second year, third year and fourth year. Because in this period he's paying at the beginning of the school, so he's gonna take the first year, second year, third year and fourth year. Since graduation there's no interest, then after that she's gonna pay back all her credits for 5 equal. This is fourth year. She graduated. Then after that she divided into 5 years plan. So the fifth year she's gonna pay like A, 6, 7, 8, 9. 7 year, 8 year, 9 year, A, we don't know this amount. So in this period, she's gonna pay for 5%, right? 5% interest rate for at the end of this period. Here's the period. Okay. How we are gonna find, first of all, A? We know that in this period there is no interest rate. So we can say 9,000 multiplied by 4 is gonna be 36,000, right? $36,000 at this place. At the fourth year, till graduation, there is no interest. So here there is an 36,000. So we can divide it into payment A. A is gonna be equal to 36,000. Then we are gonna make it A over P, which is 5% for 5 years. Then we can say this one is 8,300. 8,316 dollars is the A. We need to pay back each year. Then we are gonna find rate of return. So we know that net present worth is gonna be equal to 0 in order to find rate of return. Let's see. So we can make it this one. We can say, okay, 9,000. Sorry, hold on. How we are gonna do? We will think that the whole this cash flow analysis, if it has an I, how we are gonna solve this one? How much is gonna be the rate of return? Okay, for the government side. So the 0th year is gonna pay it is 9,000. So it's present value. So we don't need to add anything. Then plus 9,000 the government paying or the bank paying for 3 years. So P over A we are taking to the present. I, which we don't know, and for 3 years. Then minus we are gonna take. We are saying our A, right? A is 8,316. Then we are gonna make it present to annual to present, which is in the I and for 5 years. But we need to multiply this amount because this is gonna bring us till here. These guys into here, which is 36,000 is gonna be. We need to multiply by. We need to bring back to the present. So we need to multiply P over F I for 4 years because it's gonna be here, right? 36,000. So we are gonna bring back. Then this all is equal to 0. Again, we can do interpolation, or we can just like make an I net present worth of this guy and that guy. We need to find an I. How we are gonna do? We are gonna make it try an error again. Then we will find, you guys are gonna put like I is equal to, I don't know, 5 blah blah, in order to find that plus minus is gonna be 0. So I is gonna be, we will find 2.67%. so is our rate of return is 2.67%. In order to find this our equation. Let's see. So the rest yeah, this is showing the Maria's how it's gonna increase with the 2.67%, how it's gonna increase and how she's paying back, and how like it's gonna be ended up at 0. So it's the tabulated form, so we can pass by this one, and this is the how it's gonna be rate of return in student loan is showing. So it starts with the minus, then after that it's gonna increase it with like how many percent is gonna be, and with the graphical way where it's end of 0 in this point is gonna be our interest rate. This is the graphical way, we don't need to know, it's just Excel site. So I want you guys to solve these questions. A new corporate bond was initially sold to an investor for $1,000. The issuing corporation promised to pay the bondholder $40 interest every 6 months and to repay the $1,000 face value at the end of 10 years. After 1 year, the bond was sold by the original buyer for $950. What rate of return did the original buyer receive on the investment? So this one first, so B, this question's B is, what rate of return can the new buyer expect if he or she keeps the bond for its remaining 9-year life? And if this is another example, if the issuing corporation paid a 1% fee to sell the bond, what is the effective interest rate that the firm is paying on the bond? Is the remaining of this question, okay? And we here we will start to analyze the two options. Okay, you guys need to make these two options, solve it, and send it to me back by explaining it. Okay. For this week is done here. So take care of you guys.